Hi, and welcome to the 8th video in the Glacier Image Velocimetry, or GIV Toolbox video tutorial series. In this video, we're going to have a quick look at the outputs of GIV, particularly which files are saved, and how you can interpret them. So here is our folder. These are the images with which we calculated velocities. We had 4 satellite images from Perito Moreno Glacier, which was a fairly small data set. But as we saw, we were able to produce some fairly suitable results from them. In the previous video, we ran the code. So we named it video 7, and we're going to have a look at the results of that right now. So the first thing you see is that there are 4 data files within this folder. One called data figures images, which contains PNG or JPEG or whatever format you chose plots of the velocities. We have one called georeferenced velocity data, which contains the same velocity maps, but this time as geotiffs. We have a folder called initial data backup, which contains backups of the data in case it crashes at some point during the run, which isn't an issue. But if you're running, say, 10,000 image pairs, and you happen to have an error in your saving parameters, then you really don't want to have to run it all again. And you can load it all from the initial data backup. So that's quite convenient for that. And finally, there's one called MATLAB data files. I'm just going to open that right now, and you can see that there's 4 files in here: monthly averages, the raw images array, the run input parameters, and the stacked and averaged data array. If you check the previous video, video 7, you'll see that these are each of the files that are generated as GIV runs. And they're all saved here as MATLAB data files and can be loaded into MATLAB to be examined at any point down the line. And if you're sharing or publishing the data, of course, you can upload these alongside it so that anyone can see your velocity maps. Okay. So let's dive in and have a look at these plots. So you see here that there's 2 options. There's average monthly values, which will save monthly velocities. Let me open this. So you'll see here that we've only got 2 months, so these aren't going to be very meaningful. We have January and February 2020, and we can see that potentially things are moving slightly faster in February than in January, but it's really quite hard to tell with such a small data set. And more relevant, if we go back in here, we have mean standard deviation and other statistics, as it's called. And in here, you're going to have plots of, say, the median velocity, the x and y components of velocity, and the flow direction. So if I have a look at the flow direction, I'm just going to open this plot up. We can see that the majority of the glacier, Perito Moreno Glacier in this case, is flowing roughly 45 degrees, so flowing roughly in this direction. Apart from a small part in the southern zone here that's flowing closer to 150 degrees. So most of it is flowing northwest. A small zone here is flowing roughly northeast and southeast, which is consistent with what we can see in the images. You can see the x and y components of glacier flow, in case you need those. And I'm going to flick to the median velocity here. Yep. There we go. And we can see a median velocity map. In general, the median velocity map is less noisy than the mean velocity map. They are both generated just in case. The median is more robust to outliers. So I will generally use that. You can see here that there's a zone of fast flow at the center of the glacier, zones of much slower velocity at the edges, most rapid flow close to the calving front. It looks like it's produced a good velocity map. So what happens if now we want to investigate this further? So we want to extract values at specific points. We don't want to have to use this plot. So what we can do is we can go back to this menu and switch to the georeferenced velocity data folder. So if I click in there, then click into the mean, standard deviation, and other statistics georeferenced folder, you'll see that I've got the same files in here, but rather than being PNGs, they're geotiffs. So I generally use ArcGIS. So here I've already loaded in the individual geotiff images that we extracted the velocities from. So we can see Perito Moreno Glacier here, and I'm going to load the median velocity map on top of this. And what I'm going to do, I'm going to switch its colors to some arbitrary red-blue color map that's not particularly suitable because it's a divergent color map, but it's gonna be able to show the zones of fast flow nicely here. I wouldn't recommend making a plot with this color map for a figure, but just for visualization, it's okay. And I'm going to add some transparency. I'm going to say make it 30% transparent so that we can see the exact location of it on top of the image. And we can see that, voila, we can see that the zone of rapid ice flow does indeed correspond to the highly crevassed central region of Glacier Perito Moreno, that it forms a central band upstream and then expands to the whole glacier front where it's calving. And we got zones of much slower glacier flow on the margins where we can see down wasting occurring and a much lower degree of crevassing. And if we want to know the velocity at a specific point, we can use this to extract it. If we want to extract a cross-section of velocities, we can do that as well. Essentially, we can post-process these images in any way we want. And we can do the same for the monthly velocity maps. And say if you do your post-processing in a different programming language, if you like using Python for post-processing, if you want to do some statistical analysis of the velocities in R or whatever, you can load them into a different programming language from this as well. Okay, so I think that sums up pretty well the main outputs of GIV. I suggest that you now go and play with it yourself. Download some images of one of the glasses that you find interesting, try it. If you run into any errors, check back through the videos, make sure you got everything. Check in the user manual. If there's still an error and you still feel like you got everything right, send me an email. I'll put my email in the description. But yeah, I hope that the toolbox is useful for your research. And yeah, good luck.